So now that we know how to solve a system of equations either by graphing it or by using the elimination method, we are going to get into how to solve systems when they are in word problem form, so where we have to write the system ourselves. So the idea is we're going to translate word problems into a system of equation. When a word problem involves more than one unknown, so one unknown quantity, and there are two or more equations or conditions to be satisfied, a system of equations may be used to solve the problem. So the general idea is to translate words into the system of equations. You always want to ask yourself, what two quantities are unknown? So what is it that I'm being asked to find out? And assign that a variable. So those unknowns, those things that we need to figure out, they need to be assigned a variable, whether it's generally x and y. The question posed in the problem may give you a clue. So the actual question at the end of the word problem will give you a clue as to what those two unknowns are. Then you write the two equations, and then you just solve them as we've been solving them all of last week. All right, so the general steps are make sure you read carefully read the problem and underline, highlight anything that's important. Define the variables like let x equal, let y equal. Write the system of equations. Remember, as you read, the words representing the variables are going to be part of your equation. Then you solve using elimination and state the solution in sentence form. So for us, we are going to be doing everything using the elimination method. We're not going to graph these. And all the systems that I'm providing you are going to be in standard form. And they are going to be solved through elimination. So it's not going to be types of word problems where you can use the other methods to solve. Although there are many, many types of systems. So let's go ahead and get started. Go to the next page. So let's take a look at our very first word problem. George School is selling tickets to the spring musical. On the first day, ticket sales to the school sold 3 adult tickets and 9 student tickets for a total of $75. That seems to be very important information I'm going to be using. So 3 adult tickets, 9 student tickets for a total of $75. So this is all kind of one group thing together. The school took in $67 on the second day by selling 8 adult tickets and 5 student tickets. So again, this is also important information. 8 adult, 5 student tickets, and they took in $67. And we want to know what is the price of 1 adult ticket and 1 student ticket. So the question at the end generally gives away what we are looking for. The price of 1 adult ticket and the price of 1 student ticket. So we're going to define our variables as A and S, A for adult and S for student. You can technically use any variables you want. So I'm going to define, let A equal the number of adult tickets sold. Let S equal the number of student tickets sold. So I'm going to go ahead and pause and write it out, and you'll be able to write it as well. Okay, so A, number of adult tickets sold, S, number of student tickets sold. So now we're going to go ahead and write out our system of equations. I'm going to go first with the part I underlined in purple. So I know that using my variables A and S, 3 adults would be 3 times the number of adult tickets sold. And I'm going to combine that, meaning add 9 times the number of student tickets sold. And that total price was $75. For the second equation, I'm going to use the $67. That's my total, which came from selling 8 adult tickets, so 8 times A, and combining it with the student tickets, 5 times S. So this right here is my system of equations. I'm going to go ahead and solve it like I did last week. I asked myself, what can I multiply 3 to make it an 8? Nothing. What can I multiply the 5 to make it a 9? Nothing. Which means I'm going to be required to multiply both equations here by something. So I'm going to, in this case, I'll get rid of the A and solve for S. So I'm going to take the first equation and multiply it by 8. I'm going to take the second equation and multiply it by 3, but it's going to be negative to switch the sign so they eliminate. So I'm going to go ahead and multiply the top, everything by 8. I'm going to take the bottom equation and multiply everything by -3. So we end up with the following 2 equations once we multiply the top by 8 and the bottom by -3. We're going to go ahead and add the 2 equations to eliminate. So the 24A's cancel because they're opposites. 72 minus 15 is 57S equals 600 minus 201 is 399. we divide by 57 on both sides, and we get S equal to 7 after we divide. All right, so we know how much student tickets cost, and we know how many student tickets were sold, and that was a total of 7. Now let's figure out how many adult tickets were sold. So we're gonna take our 7 and plug it back into, let's say, the first equation. So we're gonna have 3 times, I'll do it at the bottom here since there's not much room on the right. 3A plus 9 times S equals 75. And as a reminder, we are using the top equation. I'm going to plug in the number 7 for S, and I'm just going to start solving from here. So 3A equals, not equals, plus 63 equal to 75. I'm going to subtract 63 on both sides, and I get 3A. These cancel. 63 minus 75 is 12. Divide both sides by 3, and my A value is going to be 4. So we know that 7 student tickets were sold and 4 adult tickets were sold. So this is going to be equal to 7, and this is equal to 4. No, backwards. This is 4, and this is 7. All right, let's go ahead and move on to the next problem. So we have a hotel room has 150 rooms. So we know the total rooms in a hotel. Those with kitchen facilities rent for $100 per night, and those without kitchen facilities rent for $80 a night. So with kitchen facilities, $100. Without kitchen facilities, $80. On a night when the hotel was completely occupied, revenues, which means how much money they made, were $13,000. So they made $13,000. Now the question is, how many of each type of room does a hotel have? So we want to know both types of rooms, meaning with kitchen facilities and without kitchen facilities. So let's go ahead and set our variable. Let's let X equal rooms that have kitchen facilities and Y those that do not. So let's write that out. All right, there we have it, number of rooms with and without kitchen facilities. So we're gonna go ahead and start setting up our 2 equations. So think about what we know. We know that there are 150 rooms, and we know how much each room costs per night and how much was made on a particular night. So our first equation is it's going to be with the rooms. So I know that there's a total of 150 rooms if I add the 2 types of rooms. So I know that the kitchen rooms, X, plus the non-kitchen rooms, added together, we have a total of 150 rooms. Also that $10, $100 for the kitchen rooms, plus $80 for the non-kitchen rooms, we made a total of $13,000 on a specific night. So I'm going to go ahead and now solve this system of equations by multiplying these by the appropriate constant. So I can multiply the top equation by either 100 or by 80 to either cancel out the x's or cancel out the y's. So in this case, I'll multiply by negative 100 because I want to make sure that the positive 100 cancels with a negative 100. And the bottom one, I'm going to leave it exactly the same. I'm not going to switch it up. It's already fine the way it is. So top equation gets multiplied by negative 100. And the bottom one stays exactly the same. So once they're multiplied, we get the following 2 new equations. I'm going to go ahead and use elimination by adding them. The 100x cancels with the negative 100x. And the y's combined give me negative 20y, and the 15,000 and 13,000 give me negative 2,000. I'm going to go ahead and divide both sides by negative 20. Y equals, the 20's cancel. 20 goes into 2,000 100 times. So we get our answer for Y, which represents the number of rooms without kitchen facilities. So this is equal to 100 rooms that have no kitchen facilities. Now we're going to plug the Y back into the first equation. So I'm going to use the first equation to figure out Y. So X plus 100 equals 150. You can probably figure out this one in your head. What number plus 100 is 150? So X is equal to 50, or subtract 100 on both sides. So we know that there are 50 rooms that have kitchen facilities in this hotel because there are a total of 150 rooms in the hotel. All right, let's go ahead and move on to the last problem. All right, let's look at this next question. The test has 20 questions worth 100 points. That's looking like we're going to annotate that. So 20 questions, I'm writing number 20 there, worth 100 points. The test consists of true-false questions worth 3 points. So true-false questions are worth 3 points. Multiple choice are worth 11 points. Now, what are we being asked to find? How many multiple choice questions are on the test? So one of my variables needs to be how many multiple choice questions are on the test, and the opposite would be how many true-false questions are on the test. So I'm going to let X represent true-false and let Y equal multiple choice questions. So let's go ahead and write that out. So now that we have our variables set, we are going to go ahead and write out our system of equations. So let's start off with our first equation. We know that there's a total of 20 questions. So we know that there's a total of 20 questions, and we also know that there's a total of 100 points for this question. So the first equation is going to be with the total types of questions. These 20 questions consist of both multiple choice plus true-false questions, which equal a total of 20. For the bottom equation, we know there's 100 points on the test, and we know it comes from 3 points for true-false and 11 points for multiple choice. So I know 3 points for the, I'm sorry, there's a mistake right there. Just fix that. So X, which is the multiple choice questions, are worth 11 points. So that's 11X, because X represents multiple choice. And then there's 3 points for the true-false. Got to be very careful not to mix these up. Are worth 3 points, and that is equal to a total of 100 points. So first equation has to do with the number of questions, 20. The bottom has to do with the number of point values. That's why it's equal to 100. So let's go ahead and decide what we're going to multiply these by to solve. So I'm going to just multiply. This time I'm going to eliminate the second equation, especially since it's a smaller number to multiply by. I'm going to multiply by 3. But because this 3 down here is positive, I need to multiply by a -3. So I'm going to go ahead and multiply these by 3. So it's -3 for each piece. So that's going to be -3x minus 3y equals -60. Bottom one stays exactly the same. Now we're going to go ahead and add these. These cancel. We have 8x equal to 40. If I divide both sides by 8, my x value is going to be 5. So what does the 5 represent? 5 represents x, which is a number of multiple choice questions. So there are 5 multiple choice questions in this test. Let's go ahead and figure out y, which is a number of true-false questions. So in this case, 5 plus y is equal to 20. So 5 plus how much is equal to 20? That would be 15. Therefore, there are 15 true-false questions. So we have 15 true-false questions on the test. All right, go ahead and get started with your practice. The first page will just be you setting up the variables and the system without solving, and the rest of the problems on the second page will be actual solving. So go ahead and good luck.